All right, 3.5, it says calculate the size of theta. Okay, great stuff. So now with this one, when they say calculate the size of theta, we really need to have a look at this one very, very carefully now, so that we fully understand what is happening here. This is where now you're gonna have to apply a little bit of Euclidean geometry rather, so that you fully understand what is happening here. All right. Okay. Looking at where theta is sitting right there, guys. There is S here. So I would like you to give attention to these three coordinates, okay? Because what I'm looking at this triangle right here, okay? I'm looking at this triangle right here. To make life easy for yourself, guys, always, because this is analytical geometry, always focus on the angle that is formed by a line together with the x-axis, okay, which is the angle of inclination. So let's have a look at how many angle of inclination do we have here. We have got, I'm gonna try to mark them here with a different color. Yeah, let me just use red. The angle of inclination we have got this one here, which is beta. Okay, it's what this line here, which is the line of SK, is forming with the x-axis. And then we also have got this one here. It's what the line, this one is formed by line SK. Okay, this one is formed by line, oh, I think I'm about to explain this thing very well, so please pay attention, guys. This one is this angle here is formed by line ST, and we know the gradients of these lines, by the way, okay, because we already did them previously. Please make sure you didn't fast forward this video, because now you would have missed out on the gradients of these lines. Okay, so now with that said, so you see we've got two angles. We've got this, you've got this angle here, you've got this angle beta here, you've got this angle here. So now what you want to do, can you see that if you've got this angle here and then you've got this one, there's this angle here. What happens when you've got angles that are like this on a straight line here? This angle is equals to this one. What are they for? Is it corresponding? Okay, yes. So therefore these angles are equal. So therefore even this angle here would be equal to the one that side. Okay, so we already know this one now. I'm just gonna color it with red here so that we know this one here. So therefore once we know this one here, this angle here beta, we can easily know this one, because angles on a straight line, they give us 180. So now I am gonna color this one with a different color, yellow rather, so we would know this angle here as well. After knowing beta, we would know this angle here, because this angle here is given to us by 180 minus whatever we got there. Okay, so therefore with that said, now theta would therefore be, we're just analyzing here, guys, we're not writing anything yet. Therefore theta is going to be, theta to us is going to be given, theta is going to be, is the external angle of, in this triangle here, N, okay, MS. Theta is the exterior angle of this angle, therefore is going to be angle N, which we got after minusing that beta there, plus angle M is the sum of the internal opposite angles. All right, so now let's go ahead and we are gonna start with the line SK and find beta. Okay, so SK is represented in a red color, so I am gonna write in red here so that you guys can follow. Okay, good stuff. So I'm gonna write in red here. Let's say now S, what is the gradient of line SK? The gradient of line SK as given previously in the previous everything that we did previously, we said that equation SK, it was given by this. If I still recall very well here, SK is given by -2/5 x minus 12. It was our equation there with that gradient. We know what to do with the gradient that is negative, guys. So we are gonna come here and say the relationship between the gradient, okay, this is what we're busy with, 3.2, okay, is equal to 2 over 2, and then the relationship is symbolized by tan. Okay, so it's going to be tan beta reference, because now I have removed the, we have therefore removed this, what do they call it, the negative sign. So we are going to account the negative side when we come this side here, 2 over 5, and then when you put this in our calculator, it will give us a reference angle of, I'm getting 158.190. This is just the reference angle, guys. So therefore, okay, no, it's not, is it really? No, yeah, it's the bigger angle. Therefore, the actual smaller angle that we need there, the beta, the one that we need there, is going to be given by 180 minus this angle here. So it's going to be 158.190, which gives us a result of 21.80. okay, great stuff. So that's how you get that angle here. So therefore I need to put it in a yellow color rather, because now this is what we got here. Okay, you can see I'm circling it, guys. So it gives us this angle right here. Where are we? So this angle right here we know is going to be 21.81. so now let's come here and calculate this one here. Let's calculate the M now. All right, so let's go to the M. M is sitting on the, is given by the line ST rather. So we are gonna come here and say, okay, ST equation is given by half x plus 6. So our gradient here of ST is given by 0.5, which is going to be equals to tan M, the M there. So therefore it means angle M is going to be given by tan, we are looking for an angle, so it's going to be 0.5, which is therefore angle M is going to be equal to, it's giving me 26.560. I hope you get the same answer, guys. So now with this, now we know this one here, it's 26 rather, 26.560. So now having that, now we can easily get theta, like we illustrated earlier, that theta in triangle, you can tell the examiner here where you are, you can say in triangle NMS, so that the examiner doesn't get confused, guys. So you can come here and say, all right, so therefore in that triangle theta is going to be equals to M plus N. Why are we saying that? Because this is the sum of exterior angle of a triangle is equals to the sum of internal opposite, Euclidean geometry. All right, I'm not gonna write it here, guys, because I've already explained this in question 3 of November 2020. I already explained it in question 3 of November 2021. Now we are in 2020, so please make sure that you watch the whole series, so that this concept really delves in your brain, so that you don't forget it and you really practice it thoroughly. All right, so now let's see. M is given by 26.560 plus what do we have here? We have got N is 21.810. Therefore theta is going to be equal to, let me check on my calculator here, it's giving me 48.37. All right, so this is our angle theta here. We managed to get it right, guys. Yeah, so please, guys, you can see that if you stick to the basics, really it will be very difficult for you not to get this one right. So please, guys, please make sure that you fully understand this. If you don't understand, please let me know, and then I will definitely do my best to assist you. Reach out to me on a WhatsApp, then we'll do my best to make sure that we work together to get those distinctions. Okay.